Hi everyone, I'm Preetha Chakraborty. Welcome to my channel. Today I'm really very excited because today I'm going to have a podcast with Bill Inmon, the father of data warehouse or the godfather of data warehouse, I can say. So there is still 2 minutes for him to join. He's a very busy person, and I'm really blessed that he accepted the invitation of my podcast. And let's see. Hello, hi Bill.
Oh,
Can you hear me?
hi, I can hear you.
Hi.
How are you today, Pritha?
I am doing good. I cannot see you, Bill. Uh, will it be?
Uh, now,
Yeah, I can see you now.
okay.
So I have started the recording of this session. I'm really excited, Bill, that you accepted my invite and you joined for my podcast. How are you doing, Bill?
I'm doing fine today.
Thank you. So and it is morning, right?
Yes, it's about 11 o'clock in the morning here.
Okay, nice. Okay, Bill. So, should I start with the topics? Like, I think,
Surely,
and there, for just for the newbies in data world, I think nobody needs your introduction, but still, just one sentence that he is Bill Inmon, the father or the godfather of data warehouse, whose books we have, read while growing up. Yeah. So, Bill, I would like to start with the topic that is a very interesting topic. And, I always wanted to know from you that what basically, how did this idea of data warehousing came into your mind? What was the point actually? Yeah.
surely. A long time ago, I was sitting down, looking at data, trying to make sense of it. I was working for a large corporation at the time, Standard Oil of California in San Francisco, and uh, I asked myself, what can we do with data? Let me explain that in the day and age when data warehouse started, it was thought that the only value of data was for transaction processing systems, that in terms of running a bank account activity and insurance account activity, buying something, retailing activity, it was thought that that's all that data was good for. And when I made the proclamation that you should be able to use data for something differently, that was very controversial at the time. Today, it's hardly controversial, but at the time, people thought that that was a very strange idea, and so with that, I began my path towards data warehousing. And I explored things. I hardly knew what I was doing when I started, but as I went through my life and my experiences, I learned more and more. So the whole notion that data could be used for something other than transaction processing was the original inspiration for data warehousing. I, you're on mute?
Yeah. Sorry. Sorry for
Okay.
that. So Bill, I understand. So any, I mean, example you can give like any disaster happened for not using data warehouse, or maybe if someone wants to do any analytics kind of thing in transactional databases, any war stories or any disaster stories you can actually walk us through.
Well, sure. One of the very first data warehouses was for the U.S. Army. And the U.S. Army was asking themselves the question, how many tanks do we have? And you would think that that would be a very straightforward, simple question, but it wasn't because they had all kinds of different kinds of tanks. They had all kinds of systems that managed and looked after tanks. Some of the tanks were usable, some of the tanks were in storage, some of the tanks were broken, some of the tanks were modern, some of the tanks were in a foreign country. And so there were all of these answers of how many tanks do I have? You had to qualify uh, the uh, the answer. So with the data warehouse, you could come along and put the different characteristics of tanks in the data warehouse. So with the data warehouse, when you ask the question, how many tanks are in the U.S. Army, you can say what you mean. But as long as you have all of these separate systems, having all of these definitions of what a tank is and what status it's in, it was impossible for the Army to say how many tanks they had. But that same phenomenon occurred, not certainly not in the U.S. Army. It occurred in banks, insurance companies, manufacturing. It occurred everywhere.
Yeah, yeah, nice, nice. So, Bill, also I'm curious, like when you proposed this thing, like how was the reaction in your pals, and which company or who were the early adopters of data warehouse?
Well, the first, okay, at the time when Data Warehouse came out, uh, IBM was really the only technology vendor in town. There were other technology vendors, but IBM was certainly the largest vendor that there was. And and IBM from the very beginning hated data warehouse. I've never understood why they hated data warehouse, but they did whatever they could to discourage people from building and using data warehouses. And again, I don't know why they did that, but they did. I think it was because at that time, um, IBM thought of themselves as the only company in the world that could build technology. And pretty much that was true. But data warehouse came along and was an idea that IBM hadn't invented. And it's kind of interesting. There was another person that came along with an idea that IBM didn't invent, and his name was Bill Gates. And he came along with the personal computer. So between Bill Gates and the personal computer and data warehousing as a concept, data warehousing was never a product. It was always just a concept, but IBM strongly rejected it, and the technicians of the world followed IBM's lead. That even though they didn't work for IBM, if IBM said they shouldn't do it, they didn't do it. So trying to talk to technicians of the world about data warehousing was an exercise in futility. The people that accepted data warehouse first were marketing people in the marketing departments of large corporations because they saw the value of being able to look at corporate enterprise-wide data. And if it hadn't have been for the marketing people, there may never have been a data warehouse because the vendors, IBM, and the technicians of the world rejected data warehouse entirely. The first company to build a data warehouse was a company called Pactel Cellular in Orange County, California. Now, you have to understand the world that Pactel Cellular was operating in. This was the very beginning of cellular telephone. And in the early days of cellular telephone, these companies were fighting for market share, for getting new customers and new accounts was what the cellular companies were fighting for. And so, for whatever reason, I still don't understand exactly why Pactel Cellular decided to build a data warehouse, but thank God they did. And so, Pactel Cellular decided to build a data warehouse. And they found that they could attract and keep customers, which at that time in the world of cellular telephones was what they wanted to do. And so what happened, the other cellular telephone companies came along and they said, oh my gosh, Pactel has got one of these things called a data warehouse. I don't know what it is, but I'm going to go tell my technicians to go build a data warehouse. And it's kind of funny because for years, the technicians have been fighting building a data warehouse. And then suddenly their management comes and tells them, go build a data warehouse. So it was because of marketing people, management, and the cellular telephone environment that we have data warehouse. Now, a little bit after that time, a gentleman named Sam Walton came out and wrote a book on the success at Walmart. Walmart, of course, is one of the largest and richest companies on earth. And in his book on running Walmart, Sam Walton mentioned that they used a data warehouse to help manage and control the inventory that goes through Walmart as a company. And so once the cellular telephone companies started to build data warehouses, and once Sam Walton told the retailers to build data warehouses, soon everybody started to build a data warehouse. But no thanks to IBM, no thanks to the technicians of the world who fought it as best they could. You're on mute again?
Hello, am I audible now?
Yeah, I can hear you now.
Yeah. So just for sorry, I think for 1 minute it got disconnect. Like the speaker got disconnected, and it is like it's quite funny that IBM rejected data warehousing concept at that time, but I like years and years later I worked at IBM as a data warehouse architect. So they finally. They finally accepted your idea, and that's why we have a data warehouse. Nice, nice. And Bill, just again, out of curiosity, maybe I'm going a little away from the topics. But what motivated you towards this data? I'm not exactly saying data warehouse, but this IT or this computer science field, basically. Are you coming from that background or how it is?
Well, I'll tell you how I got started. I got started a most unusual way. Uh, when I was going to college, I took a few courses in computer science and programming. And when I graduated college, I knew how to program. However, when I graduated from college, I tried to become a professional golfer. I actually played in a PGA a tournament, and I was a good golfer. I was never a great golfer, but I was a good golfer, and I was good enough to get in the tournaments. And so for a year's time, I tried to be a professional golfer, but I wasn't good enough to make any money at it. And so after about a year's time, I got tired of starving to death. And starving to death is not fun. And I learned that. And so I saw an ad in the paper that said programmers wanted. So I said, gee, I know how to program, and I'm tired of trying to be a professional golfer. So I went and applied for this programming job. And lo and behold, I got it and found that I really liked programming. But so I, I'm probably the only person that's ever gone from a professional golf career to being a programmer. And there may be some other people out there, but there are not many of them. So that's how I got started. Once I got started programming, then I found that I liked it, and I found that that I was good at it, and so I've been doing it ever since.
Nice, nice. And because of that only, I think we now have data warehouse and so many things, data lake house, everything. So what happens, happens for good, I guess.
I suppose,
So,
when I watch TV and see these people on TV playing golf, I often thought, gee, if I'd have been just a little bit better at golf, I could have been on TV. But in terms of making a contribution to the world, uh, professional golfers and tennis players are entertainers, and they provide us entertainment. But in terms of really doing something for the world, they don't. And I respect them. Don't get me wrong. I have great respect for them. But in terms of contributing to mankind and the way the world works, golfers and tennis players and football players and soccer players, they're nice people, but they don't really contribute anything other than entertainment. So I think that every now and then when I watch TV and see golfers, I thought, well, I could have been there, but I'm glad that I'm not because I've tried to contribute to my profession and to the world itself.
yeah, yeah, really, really, Bill. So now coming to the, I think, very controversial question, I can say. We all read Inmon model versus Kimball model. So I would like to know what Inmon has to say about that approach.
First off, I've never had a bad word with Ralph Kimball. In fact, when I was doing my own conferences, Ralph was the first person I would invite to speak at my conference. And I've been amazed at how people make a conversation about the conflict because there never has been a personal conflict between me and Ralph Kimball. In fact, it may surprise you that I recommend Kimball's approach all the time. But there is
Mhm.
a difference between what Kimball is saying and what I'm saying. What I'm saying is, uh, uh, how do you build data believability, integrity in the data? How do you build enterprise-wide data that can be used across the corporation? Ralph, on the other hand, is saying, how quickly can you build data to support analytics? And the questions may sound the same, but they're not the same thing at all. And people have confused that. I think journalists are looking for conflict, and and so they invent this conflict that they think has occurred. But so Ralph was answering one question, I was answering another question, and the world thinks that the questions are the same, but in fact, they're not the same at all.
Yeah, yeah. Inmon, can you give us some idea like when to go for your approach and when to go for Kimball's approach? Uh, I mean,
Surely.
any use cases?
Okay. If you want to build something quickly and fast, you should use Kimball's approach
Mm-hmm.
because there's no question. It's faster, it's quicker, and that's what you want. However, if what you want is enterprise-wide data, and let me explain what I mean by enterprise-wide data. Corporations had and still have lots and lots of applications there. They've got different financial applications, different inventory applications. And each of these applications was built for the specific needs of a single organization. And the problem is that the data that this organization uses oftentimes is similar to or even the same data as another organization, but their applications weren't ever built to coordinate with each other. And the definitions of data, the physical characteristics of the data, the calculations of the data are all different. So let me give you a really simple example. And this is a little bit contrived, but not so much. Suppose you are sitting in in New Delhi, and you've got a worldwide corporation, and you want to say how much money did we make this month, which of course your corporation needs to know. Well, you can go to the United States and take United States dollars and add them to Canadian dollars and add them to Australian dollars because the United States, Canada, and Australia all have dollars. And so you could go and add Canadian, Australian, and American dollars together. But that would be a stupid thing to do. You know why? Because the value of a Canadian dollar is different from the value of an American dollar. And the value of an Australian dollar is different from the value of a Canadian or an American dollar. In order to find out, answer your question, how much money do you have in the bank, you need to convert the dollars all to a common currency. That simply saying, I have a dollar here, doesn't really mean anything. And that's because the people in the United States built one system, the people in Canada built another system, and the people in Australia built another system. And so it's not as simple as simply saying, how many dollars do you have? You say, what is the worth of your dollars, which is a different question. So if you want to, now, this need for resolution of data, integration of data, goes well beyond dollars. It goes into what is a product. In one place, we call a product something that's a finished product. In other places, we have manufacturing and a product becomes a product when it reaches a certain stage of production but isn't through. In other cases, something's called a product when it's been archived and it isn't even for sale anymore. So you've got these different definitions of what a product is. Well, you can't, if you want to get an accurate answer for answering your questions, you've got to know what the definition of a product is. It's like the army and the tanks. Some tanks are in mothballs. Other tanks are in Hawaii. Other tanks are in Kansas in the United States. Other tanks are in Germany, and some tanks are old and not in use anymore. You've got to have an understanding of data at the definitional level. And so what the Inmon approach does is it takes into account that you've got to have an integrated understanding of data before you start to merge it together across the enterprise.
Yeah, yeah, yeah. Yeah, really. So very nice explanation, Bill. So that brings to my next question. That is, what is your thought on this modern data architectural patterns like data lake house, data fabric? Because in today's world, because I mean we are having lot of unstructured, semi-structured data, right? So many of the companies are shifting towards data lake house, data fabric, right? So what is your opinion into that? And yeah.
Oh, I actually wrote a book on the subject, and I could talk on the subject for a week, and you don't want me talking for a week. So I'll try to give you the best answer that I can. If you go back to the beginning, the first kind of data we ever had was structured data, data that came from transactions. That's what we had. And data management for the structured world, quite frankly, is complex to do, but at least people are familiar with it. The problem is that we no longer have just structured data. We've got textual data, we've got analog data, and we've got other kinds of data. So the definitions and the concepts that people use for data management in the structured world, in many cases, no longer apply. If you try to take what we learned in the world of structured systems and put them into the world of textual data, you're going to be very frustrated because I can tell you firsthand what you learned as a data management person in structured data simply doesn't work in the world of textual data. Let me give you one, there are a lot of reasons why, but let me give you one reason why. And that's because the whole notion of text relies upon context and text. When you're dealing with text, it's not enough to go and look at the text. You've also got to know about context. Let me give you a simple example. Let's take the word fire. What does the word fire mean? Well, if you don't know the context of fire, you don't know what it means because fire can mean something that's burning. That's one definition of fire. Fire can mean taking a gun, putting it in your hand, and pulling the trigger. You fire the gun. That's another definition of fire. Another definition of fire is your boss gets mad at you and walks in and says, "You're fired." So you don't know what the meaning of fire is until you have context. And so there is context in structured data, but context in structured data is treated very differently than context with textual data. Now, there's a lot of other issues with textual data. Uh, uh, the the irregularity of text. The thing about structured data is it's nice and neat and organized and structured. So when you say here is a column of a person's name, you can have Preetha, you can have Bill, you can have Sam, you can have Ranjit, you know that whatever's going to be there's a name. You can't do that with text. That because you can't tell somebody in text what to say. You can tell them what to say, but they can say anything they want. When you write an email, you can write anything that you would like to write. Uh, Another difference, major difference between text and structured data is the whole notion of key values. If you take a look at structured data, you find that every record in a structured environment, somewhere, one way or the other, has a key, something that you use to identify the record. But when you start to have a conversation with people, people don't normally talk with keys. It's very rare that a person even mentions a key in their conversation. And so structured data relies upon keys. Keys are not there in textual data. And, and so this is, and what I've highlighted are just two of the many differences between the world of text and the world of a structured world. Trying to use what you learned in the world of text in the structured world simply doesn't work. And then you go to analog data. Analog data is completely different from structured data or textual data. And most people don't really understand analog data. Let me give you a simple example that will help you understand analog data. Suppose you are have to protect a parking lot that you work for. You're working for a company that's got a parking lot for its employees. So what do? You put a camera that looks over the parking lot, and every 30 seconds or so, it takes a picture of what's going on in the parking lot. And in doing so, you sit there and take picture after picture after picture of the parking lot. That is a form of a machine gathering data, and that's called analog data. So what's wrong with analog data? Well, nothing wrong with analog data, but it has a whole different set of properties. One of the properties, the most defining property it has, is that only a very small portion of analog data is actually useful. So let's go back to the parking lot. What does that camera on the parking lot see? Well, at nighttime, all the camera sees is an empty parking lot, and that's kind of boring. So what does the camera see during the daytime? What the camera sees is people driving their cars into the parking lot, uh, leaving in the afternoon in the parking lot, and that's what they see. And those pictures are, for the most part, very boring. On the other hand, on a Wednesday afternoon, somebody goes into the parking lot and breaks into the car and steals something. How valuable is that information, that picture of somebody stealing something from the car? The answer is it's extremely valuable. And how much did that take up? It maybe took up 2 minutes worth of picture taking time. So here you have months and weeks of pictures, every one of which is not useful, not even terribly valuable. And then you have 2 minutes worth of pictures that are extremely valuable and important. And so that's what we mean by saying that analog data has a whole different set of properties that than textual data or structured data. And now analog data has, in the world of textual data and structured data, we have ETL, extract, transform, and load technology. And ETL technology is used to go into files, look at the files, transform the data, and put it into a useful state. In the world of analog data, we have something quite different. We have something called distillation algorithm that with a distillation algorithm, you don't want your person or even your machines to have to sit there and look at hour after hour after hour of useless data. That's a waste of time and money. What you want is a way to automatically distill the data and find what data is useful and what data is not useful, and then pluck out the data that's useful and separate it from the data that isn't useful. So data management has greatly changed due to the change in data that we find in the world today. Now, there's a difference as far as I can tell, there's a difference between a data lake and a data lake house. When a data lake came into being, the idea was simply to take all of this data, throw it into a pile, and hope somebody can make sense out of it. And that, as far as I was concerned, was one of the biggest mistakes and biggest messes that people ever made. Whoever thought up a data lake uh, was not a professional that knew what they were doing. I don't, by the way, I'm happy to say I don't know who that person or organization was, but whoever that came up with the idea of a data lake should be banned from our profession. However, there's a lake house, and the work on lake house was generated originally by Databricks Corporation, but other people use the concepts now. And with the data lakehouse, there's a very different notion of not just putting data into some kind of store, but putting metadata into the store and doing integration of the data as it goes into the store of data. So a data lake and a data lakehouse can contain structured data, analog data, and textual data. So the data lakehouse is much more of a professional approach towards data management than a data lake ever was. So that's a long answer to your question.
Yeah, it was really nice and insightful, Bill. And like, what about data fabric? And I also, I think, read one of your posts where it was written, "Be aware of data fabric." What you have to say about that?
Uh, Data Fabric has an appeal to people that want to distribute data. But and by the way, I'm not an expert on Data Fabric, and I want to make that clear.
Sure.
I've read about it, but in terms of actually doing it and touching it and working with it, I am not an expert. But the thing that I think that I found missing with data fabric is the whole notion of the integrity of the data. That somehow they've missed the fact that data is in a mess, and it before it becomes really useful, it can't be in a mess. So I've looked at both data mesh and data fabric, and neither of them seem to understand that if you don't have a foundation of data that you can rely upon, then all of the architecture in the world that you put on top of it is really not going to matter.
Okay, okay. So now coming to my next question, that is, and I understood whatever you said, and your opinion on data lake and data lake house, and I also feel the same. But I'd still like to understand what is your thought on modern days cloud data lakes, because Amazon has S3, which is object stored, file stored, GCS buckets we have where we can store multiple types of files, and we call it data cloud data lakes, right? So what is your thoughts on that, and also what is your thought on a cloud data warehouse?
Um, you've asked several questions. I'll try to answer them as best
Sorry,
I
sorry
can.
for
No,
that.
it's fine. It's fine. But you confuse me. My I have limited capacity in my brain, and I get confused easily. Uh, it's one thing to store data. We certainly have to store data. No, there's no question about that. But it's one thing to store data. It's another thing to use the stored data. And so the vendors love to store data. They're good at it, but and that's what they sell, and they tell people they need that. And do you need to store data? Absolutely, yes, you do need to store data. But just because you store data does not mean that it's useful. That it's not useful to go into the store of data, and it's not useful to go across stores of data. So I guess I blame the vendors for focusing only on one aspect of the need for storage of data. Uh, Shame on them for leading the world into the mess that the world of data is in today.
Okay, okay. So my next question will be like, what is your thought on SQL versus NoSQL for data warehouses?
I'm sorry, I didn't understand that. Could you repeat the question?
Yes, yes. So what is your opinion or thoughts on SQL versus NoSQL in terms of data warehouses?
Their languages, their tools. Uh, that's like asking if you go into the Empire State Building, what do you think of the doors and windows in the Empire State Building? Well, they're interesting. They're there, but in terms of the value and the architecture, they're only they're uh, they're a contrivance. They're they are part of the architecture, but they're not a they're not the essence of the architecture. So I mean, they're tools, and they're perfectly good tools. But if you think that getting SQL or no SQL is going to lead you into the world of a proper architecture, then you don't know what you're doing. That
Mm-hmm.
you don't know what you're doing. That there's so much more to an architecture than just the tools that you have. So, what do I think of SQL and no SQL? They're tools, and they're apparently pretty good because people use them.
Yeah, yeah. And Bill, I mean, what is your like maybe thoughts on, like, how relevant in today's modern data architecture, how relevant good data modeling is?
Data modeling. Data modeling is at the heart of being able to integrate data and at the heart of the integrity of the data. That uh, a data model is like a map on the ocean. Suppose you're in a ship on the ocean and your ship is a wonderful ship, it goes everything. If you don't have a map, you don't know where you're going. There's an old saying
Exactly.
that if you have no destination, any setting of the rudder will be just fine. And that's true. That the data model gives you a map of where you need to go and what you want to do. So I personally think data modeling is an absolute necessary thing to do unless you like being lost. If somehow you like being lost on the ocean, then you don't need a data model. But if you want to take your ship to where it needs to go, you need a data model.
Yeah, yeah, agree. Because in today's trend, you will see many of the discussion happening or blog. I mean, posts are there. Like now we have data lake, we can store data as is. We don't need to invest time in data modeling. But as you say, like then the data lake will become a garbage dump, like that if proper.
And people that say that we put data into a data lake and now it's done are the vendors that say all there is to it is storage. There's storage. It's like a ladder, and storage is the first step up the ladder. But if you want to get to the top shelf, you've got to go up a lot of other steps other than just how to store data. So storage of data is necessary, but it's not sufficient.
Yeah, yeah, agree. So now, my next question will be, what is your thought? Like, what do you think about, like, how AI will change data warehousing industry? I mean, will it change or how will it change? What do you think about that?
I'm sorry again. How will what change the industry?
In every industry, we are seeing impact of AI, right? So how artificial intelligence
Ah,
will change data warehousing industry? What is your thoughts on that?
okay. I'm going to have to answer your question with a lengthy answer. I want to go all the way back to the beginning. In the beginning, we had the early computers, and they served the business community. And this was IBM and the mainframe. And then one day, this guy named Bill Gates came along and he brought in the personal computer. And with Bill Gates and the personal computer, the whole audience of who uses a computer changed. Instead of business people being the only ones that could use a computer, with the personal computer, now anybody could use the personal computer. And so the personal computing changed the whole face of what is computing. Today, with AI and ChatGPT, we're seeing the same thing. What we're seeing is that ChatGPT has opened up the world, and not to people that can afford a personal computer, but to anybody that can get on the internet. And with the interface of being able to have a language interface, it has opened that up. But the kinds of questions that were answered. Let me go back to the starting analogy. When you had business people only using the computer, they were asking business questions. And when the personal computer and Bill Gates came along, did they change the world of business computing? And the answer is not really. They opened up a new audience and opened up a whole new way of computing. But in terms of solving the problems of business computing, the personal computer really didn't do very much for that. The same goes for AI and ChatGPT. What AI and ChatGPT have done is opened up the world to a whole different line of questions. That being able to say, what was Columbus's ship name? Being able to say, who won the Prussian War? Being able to ask all kinds of questions, ChatGPT is opened up to that. And that's kind of interesting. However, when it comes to business value, people are finding out that AI and ChatGPT really haven't helped much with business value. There was an article in the Wall Street Journal this last week about that very topic, that our corporations are rushing to employ ChatGPT, but in terms of improving the profitability of the corporation, ChatGPT isn't doing that. And so we have these new advances in technology that are very exciting, very elegant, but in terms of so what these new opportunities in technology are doing is opening technology to people that couldn't ever have used it before. But they're not going in necessarily and solving the business problems that already exist. So to be truthful, I've talked to several organizations about trying to use ChatGPT to solve business value. And the answer is the results have been very disappointing, that you really don't find artificial intelligence was ever aimed at solving the business problems that exist today.
Okay, okay, nice, nice. Uh, these are really insightful. Now, I was checking your ventures, and I found something very interesting, that is textual ETL, text analytics, and I believe your current venture, Data Works, is working on that. Could you elaborate us on that?
Surely, textual ETL is technology that reads raw text and turns raw text into a database. And you can read it in any language. You can do you identify the context. You have when you're dealing with text, you must have context. That's what textual ETL does. So you say, well, what is the value of reading raw text and turning it into a database? Let me give you one of many examples that are out there. Let's take medical records. That in a typical medical record, what you find in the typical medical record are doctor's notes. You find structured data about blood pressure and gender and age and things like that. But the really interesting part of a medical record is in the doctor's notes. The doctor's notes are in the form of text. So if you want to be doing medical research, can you do medical research on doctors' notes that are textual? The answer is yes, you can, but you can only look at so many records. I've asked any number of doctors, how many records have you ever read in doing research for a patient? And the most number I've come up with is one doctor said he's actually looked at 25 medical records in doing research. And why? Because you have to manually read the record itself. So, what if you're dealing with a very large disease, cancer, COVID, diabetes, nephrology? The world has got all kinds of very bad diseases. You can't look at 25 records. You've got to look at thousands of records. Why is that? Because the patterns you're looking for when you look at major diseases are not patterns that will ever show up in looking at 25 records. You look at 25 records, and there could well be patterns there, but you'll never find them. In order to find the patterns, you've got to look at hundreds of thousands of medical records. So if you say, gee, I've got to look at 100,000 records, how do I do that? I have news for you. You don't do it manually. You've got to have a computer to do that. So if you can take the doctor's notes and turn them into a database, now you can look at 100,000 or even 1,000,000 records and find information there that couldn't be found. Now that's just one case of why that is important. There are lots of other reasons why going from, let me give you another quick one. Let's talk about corporate contracts. Corporate contracts are in the form of text. That's how corporate contracts exist, as well they should. Uh, if you go and ask an executive, Mr. or Ms. Executive, have you do you know what's actually in your corporate contracts? And I've asked this question to executives around the world. And today, not one executive has ever stood up and said, oh, yes, we know it's in our corporate contracts. Instead, I get, oh, Bill, we've got 1,000,000 contracts. There's too many. Or, gee, Bill, every contract is different. And how can you deal with that? Or, gee, Bill, we've run our company for 50 years without knowing what's in our corporate contracts. We don't need to know that. And I got news for you. All of that are excuses because, first off, you can know what's in your corporate contracts down to the penny. And I once told a company, I said, they asked how much I wanted to get paid. And I said, all I want from you to pay me is 10% of the money I can make your company by allowing me to look in your corporate contracts. And if they would have let me do that, I'd be a rich man today. But they said, oh, we can't pay you like that. We have to pay you by the hour. Well, I don't work by the hour, but because I get there is a wealth of important financial information that's sitting there in your corporate contracts that no one is looking at. No one. And by the way, I know how to find that. And any corporation out there that wants to make me that deal, give me 10% of what I save you. I'll be happy to do it. You won't be happy paying me the money you do, or maybe you will be happy. You ought to be happy because you're going to be making 90% of what I'm making. But the bill I'm going to be sending you is the biggest bill you're ever going to get. So anyway, that's another example of the value of being able to go from text to a database. And I could be here for another week talking to you about the examples. So that's what textual ETL does. That's what textual ETL does, and it's very interesting technology.
Yeah, yeah, sure, sure. So I will definitely love to hear from you, and I will definitely read your books. I have also ordered one, which I saw for unstructured data processing. There is a book. So it's I mean your obviously your posts and everything is very very insightful. So one curiosity will I have. So since you are working in this field from the very beginning time, right? So which database maybe you have used first in your life?
Uh, uh, the first usage of data wasn't even in a database. I actually, a long time ago, programmed in machine language. And then we got
Oh,
to assembler. And then we got to Fortran. But you mentioned starting, I have to interject something that speaking of books, I have a new book coming out in about 3 weeks' time that's on the history of computing that let me tell you, a while back, I was at a conference and I was sitting at a dinner table surrounded by people that are all professionals in our world. And I mentioned casually that a gentleman named Ed Jordan had died. And not one person at that table knew who Ed Jordan was. And then I mentioned Grace Hopper, and they didn't know who Grace Hopper was. And then I mentioned Gene Amdahl, and they didn't know who Gene Amdahl was. These people and our profession is filled with pioneers of people that people don't even know the names of it. And so with that, I have a book coming out 3 weeks from now on the history of computing. I wrote the book with a most interesting gentleman, a friend of mine, who happens to be one of the original founders of Apple computers. And he worked with Steve Jobs and Steve Wozniak. His name is Roger Watley. He was a professor at Stanford. He has a PhD in electrical engineering. And he was telling me, my friend Roger actually has the very first Apple One wired board that was ever made. And I told him that Roger, a museum is going to pay you a lot of money for that because there's only one of them and it's famous and he owns it. But between Roger and myself, we've worked with many of or knew many of the early founders of our industry. And like Gene Amdahl. Let me ask you, Preetha, have you ever heard of Gene Amdahl? You probably
I
never have.
No, I'm
No, you
sorry.
haven't. Okay. Gene Amdahl had one of the most profound impacts on our industry of anybody. Let me tell you what Gene Amdahl did and why it was so profound. And everybody's forgotten Gene Amdahl's name, but Gene Amdahl was the person who recognized that you could put the internal wirings of a computer such that software could be moved from one computer to the next. Once
Oh,
upon a time, every computer was different. And not only was every computer different, but the data going through every computer was different. You see, today we think, gee, Bill, I can run this on Windows. Well, there wouldn't be a Windows if it hadn't been for Gene Amdahl. Or PDF. Gee, Preetha, I can send you something in a PDF. Well, you couldn't do that because I would have my computer and my computer's definition of data would be completely different from your definition of data. And I would have a Microsoft program, I can't think of, on my computer that I can run, and I could send you the data and you could run it on yours. But you couldn't do that without Gene Amdahl. Our computer industry would be completely different than what it is today had it not been for Gene Amdahl. And yet people don't even know his name. And there are a lot of other people out there: Ed Jordan, John Zachman, Grace Hopper, Charlie Bachman. At any rate, and, and then you get into the really early days of the computer. Where did the Hollerith punch card come from? The Hollerith punch card, you got me off onto a subject. The Hollerith punch card came originally from Persian rug weavers. If you've ever looked at a Persian rug and seen the ornate designs on a Persian rug, and a Persian rug is woven one strand at a time going one way, the next strand coming back going the other way. How did the rug maker know to put a blue strand here and a yellow strand here and a red strand here? Because with the ornate rugs they have, it's very complex. Well, they developed the very first version of how to keep track of that. And that was the origin of the Hollerith punch card. And then from the Hollerith punch card developed the player piano. If you've ever looked at the insides of a player piano, what the inside of a player piano is like is a piece of paper with holes punched in it. And they've got this reader in the player piano that sits there and senses where those holes are. And that tells the player piano how to play the piano. And so the player piano borrowed the technology from the Persian rug weavers, and then Herman Hollerith, who made the punch cards, borrowed the technology from the player piano. And so our industry goes back the okay, don't get me started on this because the abacus came from Macedonia around 3,000 years ago. Then it went to China. Venture capitalism started in Boston, Massachusetts, with whaling ships. So there are many fascinating stories about how did our industry get to where we're at today. And that book is coming out in about 3 weeks. And Roger and I and our spouses are going to go have a party together.
Sure, I mean, really nice. I would really, like, love to read that book. It's really, really nice. Bill, I just missed one question when you were talking about textual ETL. So, are you using any kind of like NLP technologies, any large language or small language models to process the textual data, like, or it is a different
We
algorithms?
went through the whole progression of data modeling. We started with language modeling. We started off with an LLM, quickly discovered that wasn't workable, went to an SLM, quickly discovered that wasn't workable, then tried to start to focus our data models, our language models, and then we ended up with something called a business language model. And we built a library of business language models so that we can go into a business and understand the business language itself. And I recently had an article published this week in LinkedIn on business language models. If you're ever interested in a detailed discussion, there are lots of stories about a business language model, how it works, what the components are, and I'll be happy to talk about them. But probably not today because my voice is getting hoarse from talking all this time.
Sure, sure. Yeah, definitely. Definitely. I will check out in LinkedIn. So that's great to hear. So I'm done with my technical, all this technical topics, Bill, and it was really, really insightful. So if you have another 2 minutes, I would like to know about a little bit of your personal life, maybe your hobbies, what you like to do apart from research and publication.
Surely. I live in Denver, Colorado. We have had a most beautiful fall that we're having. The snow is coming. In fact, it's already starting to snow up in the mountains in Colorado. I'm married. I have a wonderful wife. My wife is a doctor, a medical doctor, an emergency room. We have two dogs, two Scotty dogs, and I play with my Scotty dogs. My uh, I have two hobbies in life, one that I get to do every day, one I don't get to do very much at all. I am the cook in our house. My wife was a doctor and was so busy being a doctor, she never really spent much time cooking. So I'm the cook in our house, and I experiment with new dishes. And there's some things, actually, I'm not a professional cook at all, but there's some dishes I can do really well. There are other dishes that I don't do so well. The other hobby that I have that I don't get to do very often is go fishing. I go with my daughter lives in Miami, Florida, and when I go visit my daughter in Miami, we always go out to the ocean and go fishing and have caught some really fun fish out there. So those are a little bit about my personal life. I'm a workaholic. I work 7 days a week, and but I love to work, and I love to work. So that's a little bit about me.
I also heard that you are a car freak. You love cars and driving.
I love what?
Car.
Well, I used to. I used to. I once collected cars. I had a 308 GT Ferrari, and one of the happiest days of my life is when I got the Ferrari. The next happiest day of my life is when I got rid of the Ferrari. There's an old joke. How can you tell if a Ferrari's been down your street? Is if every 10 feet there's a spare piece of equipment that's fallen off the Ferrari. My piece Ferrari was beautiful to look at, but was a piece of junk. I also have had Porsches. In fact, I'm planning on getting another Porsche. It'll be my seventh Porsche that I've had. I currently don't have one, and I miss it. Porsches are as well made as a Ferrari is not well made. And now I hope Ferrari has improved their manufacturing process because they do make beautiful cars, but boy, you don't want to own one. So yes, I do mess around with cars.
Yeah, nice, nice, Bill. So I got to know about three of your hobbies and also your golf journey. Apart from our entire discussion on data warehousing journey, so it was a wonderful, wonderful podcast. I got a lot of knowledge, and I also made some pointers. I will definitely go and check out all those things. I will Google about those, and I am again now I'm excited for your book, History of Computing. So
It'll be
uh
awesome.
it's nice to meet you. I think I took a lot of your time now. Yeah, now.
Not a problem.
Yeah, thank you.
Thank you for our conversation, Preeta.
Thanks, Bill. Thanks for joining. Have a great day. thank
Same to you.
Thank you. Bye. Have a great day.